This is one of my favorite labs because I like to show you something based on real world networking and not just always according to theory or according to Hoyle, however you want to put it. And this one definitely mirrors more of a real life situation that I faced as a senior network admin for a company here on the East Coast of the United States, where some of their, let's say the hubs were in major cities, but some of the spokes were pretty darn rural, and the networking connections were not always the best. So on occasion, we would make a decision to not use a routing protocol over a link to some of those spokes because the connectivity just wasn't there. The links would either flap or they'd be unavailable for large amounts of time, and we decided we just didn't want the overhead. Sometimes a static route can actually be better, and that's fine, but the decision to use a static route in a situation like that can make using a backup route a little tricky. Now, if that sounds a little fuzzy to you, that's fine because I'm about to unfuzz it for you with this diagram. And here's our lab. Because here we've got two links, two different ways for packets to get from router 1 to router 2's loopback. Over the broadcast segment, fast Ethernet network of 12110/24, or over the serial link through the service provider cloud at 21110/24. Now, we've seen a network kind of like this already, and you put RIP on it. We know we'd have equal cost load balancing, etc. But in this particular case, what's going to happen is the client has come to us and said, hey, that serial link, it's not particularly strong. It flaps a lot. I don't want any routing packet overhead, whatever the client says. Because whether it's an unstable link or an unstable client, why not both, right? On occasion, you can have something happen like this where the client just says, hey, I don't want a routing protocol configured on that serial link. So, but they do want a backup link because since router 1 can reach router 2's loopback in two different ways, we love that. We love the redundancy. But again, in this particular lab, we've been told that serial link is unstable. And that leads the client to make some unusual requests. First off, in this lab, we're not allowed to run a dynamic routing protocol over the serial link. We are going to use RIP over the broadcast segment, the 12000 segment, and the serial link, that network should be used to reach router 2's loopback only if the RIP route for that network actually leaves the table. So that RIP route has to be totally gone in order for us to be able to use that 21000 segment. So this is what we're actually going to do here in a moment. I have not pre-configured RIP. But what we're going to do is configure RIP version 2 over the broadcast segment and on router 2's loopback, but we are not going to configure it over that serial link. Little different here, so let's go ahead and bring up the pod and on router 1. What are the first two commands I want to put here? And the order doesn't matter, I admit, but the first two commands you're almost always going to put under RIP. No auto, and version 2. And I'll go ahead and put the network statement here. And then router 2, almost the same thing. And we need one for that loopback. And let's go on back over to router 1. First we'll run show IP protocols, just review a couple of these very important commands. And we do see version 2 all over the place there in the middle. We see automatic network summarization not in effect, exactly what we expect to see. There's the routing information source, gateway 12112, the downstream router, AD of 120, and last update came in a few seconds ago. So it's all good there. And notice, of course, it's running on fast Ethernet, RIP is, that is, but we are not running anything over the serial link. So let's go ahead and run show IP route RIP and take a look at all the RIP routes in our IP routing table. And as we expect, there's 2220 and everything looks good. Expected next hop, expected interface, everything looks as expected. And of course, what are we going to do now? We're going to ping it and make sure we can reach it. Okay, but I pinged it, but how do I absolutely positively know that somehow these packets aren't going over that serial link? What am I going to do? I'm going to trace route it. That's going to show me, in this case, one address, because it's going to show me the very next top address, 12112. We have verified that everything is going over the broadcast network. So, what? Excuse me, that obviously should not have happened. And let's go to that drawing instead. So right now we've got all traffic going to 2222. Everything's beautiful. Couldn't be better. But we're always waiting for that next shoe to drop. We don't want to ignore that serial link. And right now, if that route disappears from router 1's routing table, what's going to happen? Well, there's nowhere for the packets to go, right? As a matter of fact, let's go ahead and test that. And the quickest way to do it is to go over to router 2 and take network 2 out. And I'll force an update there anyway. And we'll see if we still see the route, and we don't. So the RIP route to network 2 is gone. So what happens if I try to ping 2 now? The packets are just going to time out because we don't have any gateway of last resort. There's no default gateway here. So we know beyond a shadow of a doubt that the packets are going over our broadcast network. And we also see now that if that route disappears, router 1 cannot communicate with router 2's loopback. We want to fix that. We want to fix it so the serial link is used when that RIP route disappears. So before we proceed with that, and before I forget, let's put network 2 back in the mix. And we'll go back up to router 1, see if we see it yet. That should have forced an update. We can just make sure everything is back the way it was. It was and it is. So we're gold. So if we can't go dynamic, how are we going to go? We're going to go static. We're going to write a static route that will send traffic over the serial link, and then we'll test our connectivity, see everything that's going on. So we know the syntax for our RIP route is 2222 there. We're going to put 0. And we're going to put the next top IP address, which was 21112. And there's our static route. So can I still ping 2222? Sure I can. Nothing has changed. And let's go ahead and do a show IP route RIP. And my RIP route is gone. Why is the RIP route gone from the routing table? I didn't take it out, anything like that. We put it back in up here on router 2. There it is on router 1. I sent my ping, I sent my trace route. The only thing I've done is added that static route to 2220 using the serial link. So why is the RIP route gone? Let's do a show IP route static. And there it is. There's the static route. Let's use another command here, show IP route 2220. And we see it's known via static. And let's go ahead and send a ping. We know we've got connectivity, but let's run traceroute 2222. And look at that next top IP address. It's changed to 21112. So right now, just by writing that IP route command, all the packets going to network 2's, or router 2's loopback network, I should say, are going over the serial link, which is exactly what the client didn't want because it's an unstable link. Why did that change? Because I wrote that static route. We're going to talk about that at the beginning of the very next video, and then once we identify the problem, by golly, we're going to fix it. See you there.